Hello, welcome to today's class on AutoCAD Electrical. Today we'll be treating Module 9 and our topic is load distribution in buildings. What it involves is that we're teaching about load distribution, creating a load schedule, components of a load schedule, grouping components into subcircuits, calculating the load current in amperes, and we'll be assigning them to the MCB, that's the miniature circuit breaker. Again, we'll be calculating the total load and power in the whole building in kilowatts. Now, this part of an electrical installation design is the technical part. It involves the technical know-how. So here there's a lot of mathematics, a lot of calculations that will come in here. But don't get scared, it's a simple calculation and you're going to go through everything in steps. Okay, to start with, you're going to go to our AutoCAD environment. Here we'll have our design and we'll be doing our design proper. Okay, as you can see here, this is a load distribution, and these are the load schedule, how we schedule the loads across the distribution table. Now the whole of this becomes a DB, that's the distribution board. Distribution board is where all this falls on. Okay, what you're seeing here is the load schedule, how everything is arranged in the DB. Like I said earlier, this is the technical know-how for an electrical installation designer. Okay, we're going further, we'll see how to come about this. Okay, I'll explain this now. First, you have a distribution board using D4. Okay, what we mean by distribution board using D4 is that the D4 symbolises the way. We have here D1, D2, D3, and D4. D4 is the number of ways we have here on our distribution board. Okay, we have the phase. In a distribution board, we see that we have the red, yellow, black, red, yellow, black, red, yellow, black. It is arranged in that format, and it goes on as the number of way increases. For the D4, this is the red, yellow, black continues. So as you can see, for a D4, we just have red, yellow, black, red, yellow, black, red, yellow, black. That's what we have here. Okay, for the circuit number, they are arranged in ascending order. So as the phase and the phase increases, we are using increasing number. So we have 1, 2, 3, 4 to 10 here. For this, the sub-circuit is what we've done formally. Our luminaries and our power layouts, when we did a sub-circuit for them, the sub-circuit will be arranged here according to all the sub-circuit, whatever we use in our design will be arranged here. Then the number of points of this sub-circuit will be placed there. For example, SAC7 has just 1 point, SP1 has just 1 point, so that's why we're having one point in it. If we are using luminaries, let's say the lighting, for example, and if this is the lighting and it has 10 points, we'll have 10 number here. This one has, maybe this is fan and it has 5 points, we'll have 5 number here. So that is how it's arranged. The MCB rating. The MCB rating here depends on what we are loading, what each of these implies. For example, what we have here is that we have 20 ampere MCB. Now the 20 ampere MCB is what is used on this AC point. For example, this SAC and is an AC point. So the 20 ampere MCB is a circuit breaker which the AC is connected to on the DB. This plug on this DB is able to carry AC of, let's say, 4,000 watts. This is SP1. SP1 normally signifies our starter pump. So that means we are using a 20 ampere MCB as the circuit breaker we are using to regulate this water pump. It's here, the starter pump. For the SCC, that's the thing, that's the cooker unit. One cooker unit, but we are using a 30 ampere, which has increased. This means that at the rating of the cooker we will be using is much more than the rating of the AC and that of the pumping engine. So the same thing goes to all these: the microwave and the other, the water heater. These are water heater 1, 2, 3, 4, and each of them is connected to 25 ampere circuit breaker on the distribution board. So that's how we know our circuit breaker. Our cable sizes. Cable sizes we'll be using also will reflect here on the load distribution. Now for this SAC, we're using a 4mm square cable. For the cooker unit, we're using a 6mm square. For the EX, we are using 3. That's the X. In the kitchen, where we have our exhaust fan kitchen, that's it. This is the microwave oven, using a 4mm square meter, using a 4mm square cable. For the water heaters, we have a 4mm water size cable too. The diversity factor. The diversity factor implies that the amount of load that will be diversified when a particular source of current comes into the grid. For example, what we mean by diversity factor is that in our homes, when there is power supply, we tend to reduce the amount of wattage that is used. So we try to put off some lights that are not needed, put off the fan if the AC is on, or put off the AC when the fan is on. By that, we have diversified the energy. Hence, we have a percentage of power being used. So when we have 1 year, that means the full power is used at the power supply, so everything is on. That's why we have a diversity factor of 1, so it is completely 100. The load we have here is the rating of each of the appliances we'll be using. For example, the load is in kilowatts. For example, our SAC, that's the AC point, that's 2 kilowatt. That means we have 2,000 watts. The AC we're using is about 2,000 watt AC. The SP1 is the pump we're using. It's a 2,000 watt pump. The cooker unit, we have a 5,000 watt. That's a 5 kilowatts. For this we have 3 and the rest. Then for our water heaters here we have 3,000 kilowatts each water heater. Then if you add up all the total load here, you have 33. Simple as that. For if this is a building and they've done everything about the putting. We're having an estimated 33 kilowatt per day that has been loaded to the building. 33 kilowatt. Now, for easy distribution on the phase on DP, we try to spread out the connection there, and what we used to do is that at the end of the day we should be able to know the amount of load going into the red, the yellow, and the black phase on the distribution board. Okay, what we're doing is that we're rearranging these randomly but systematically. Here we bring down those two, here we bring in two, we brought 5 down here, 3, 3, 6. Now this 3 is here, this 3, we have this 3 here, we have this here. Now at the end of it, we'll sum up for the red, the yellow, and the black. Now take note, when summing up, making this arrangement and summing up these, they must have an average or closely related sum. That's why we're having red, we have 11, yellow 11, and the black 11. So that is about the distribution board, the load distribution. What we're doing now is how to prepare load distribution and how to know how to use to impute each of all these. For example, I have this. I have this as a plan, and we've done our power layout. So using this power layout, now we have subcircuits like S1, S2, S3, and we also have S microwave, S cooker, S exhaust exhaler here. So as you can see, we have different components there. Now these components are what will be inserted into these are the circuit, sub-circuit. These are what will be included there. Okay, here we have a load distribution D6. Now remember I said this is a D4 because we have 4 points. Here we have a D6. As the number increases, so does the rate increase. So it's a D6 distribution board. Now what we're looking at is how to put up a load distribution and how to calculate for the load and everything. Now to put up a load distribution, we have already done subcircuit, we have already done everything you need. Now we construct the table first. This table will have just like a replica of this to have everything here. Now this table will contain the weight, phase, circuit number, subcircuit, number of points, MCB rating, cable size in millimeter square, diversity factor, the load in kilowatt. Then it's going to have the phases here. Alright. Okay, to start with, we're going to draw a rectangle. Then with the lines and side of the lines, then we impute the way. The way depends on the way is the load distribution table, and it will help us to know kind of dB the distribution board will be getting. That's in this system. Now to know what kind of dB is the sub-circuit when it is arranged. As you can see, the sub-circuit is arranged from L1 down to SA6. Now once it's arranged up to this point, that means we are using a D6. We're using a D6. So we could put up these after you put up the table and the lettering here, then we could start on how to fill this part. Now to fill this part, you fill the circuit number, you have filled the sub-circuit from L1 down to this. And the number of points, you go to L1 and count the number of L1 you have there, number of points there. You go to L1 and check. Like we have here L1, you have L1, you have here L1, you have L1 and separated like all through the round of the building. So you can see the number of points on the L1, then we'll call it number of points L1, we call it 20 points across the building. So 20 points has a total MCB rating of 10 ampere. So the same thing we will do for the LA1. You count the number of points to 1, L2 8 points, L3 13 points. Now each of all the subcircuits has a number of points to put them there. The MCB rating. Now the selection of MCB rating, the circuit breaker plug on the distribution board. For this part of it, what we do is that to know the actual MCB rating we'll be using the load amount for that particular subcircuit L1. The load amount in kilowatt, then we're dividing it by our supply voltage. That's about 220 to 230 volt. So if you have 2000 watts, yeah, and you have 220 kilowatts, then dividing that, we'll be having up to 10 ampere. You're having less than 10 ampere current. That is saying 2000 divided by 220. So you're having less than 10 ampere. Now, since you'll be having less than 10 ampere, it means that the circuit breaker that's up to 10 ampere will be used to control the L1 on the distribution board. For the L2, you can see LA1 here has just 1 point, and it has just 1 kilowatt and 1000 watts. So it has just 1000 and it has one number of points. So 1000 divided by our supply voltage to phase. So if 1000 divided by 20, we have about 4 points. That's for our load current to be about 4 points. Now 4 points is maybe 4.2, 4.1. Then MCB rating is 5 amperes. What we are doing is that if the rating is 10 ampere, you can't load it with 10 ampere exactly. You can load a 9.8 load a 9.8 ampere to a 10 ampere MC, but you don't load 11 ampere to 10 ampere MC because the load there is greater than the rating for circuit breaker. Hence, it will damage that point on each cable. So by that, we will be able to know the rating of all the sub-circuits we have their rating. For the cable sizing, we have different cable sizes for different objects. Like we have one are just the lighting. So the cable size is using for just lighting. So we are using 1.5 mm square for lighting. Then from here we have S1, these are for sockets. The socket we are using 2.25 millimeter square, 2.5 millimeter square as our rating. Our cable size for the socket S1 to S4. Then for our powerful appliances like the AC, heaters, they are having a 4 mm square cable size. For those here, that's the AC point water heater, they are having a 4 mm square. That's the size. But the diversity factor, it depends on your client. If your client tells you that when there's NEPA supply, when there's supply of electricity, we tend to put on everything on the video. Hence our diversity factor will be 1 because nothing is going off. So that's why we are having diversity factor of this. Here we are having diversity factor of 3.7. That means 70% diversity. Okay, we have the rest are just 1, which we have. When we have 1 here, means that there is no changes between the different sources of power. Okay, our load is at the end of the day we calculate our total load and we have it in 6.7 kilowatt. 6.7 kilowatt, and then we have to reassign them into different points of deep spark plugs. That's the circuit breaker we have here. So we arrange this to 2. Whenever you are arranging this, you must adhere to the instruction that it should be on an average. You shouldn't have maybe one is 20, then you have the other one is 1, and the other is 30. So to make it even, we try to split all the load across, and then we are having 9.1, 8.9, and 8.7 for each of these. So that's our load distribution table. At the end of today's class, you should be able to create this table, fill in the values, and try to understand how we come about all this. At the end of today's class, you should be able to put up this design and the lines, put up the text, and also this. Then you can compare this with what you have. So by the end of the class, we be able to design a load distribution table for our work, and should be able to schedule everything on the table. Thank you for joining us in today's class. We have completed the load distribution. This is a sample of load distribution. You should be able to create this and fill it up. So we'll be ending our class officially today. So that is the end of load distribution. We'll be seeing more about load distribution where we go into our full project. Thank you for joining us.